Okay, welcome America. Today we are going to continue our material on circles, and we're going to learn about inscribed angles today. So, without further ado, this is a picture of Chris's bird, Nico. I believe that is a parakeet.
It's a cute name for a bird.
It is cute. He looks like, he or she looks like I think it's a happy bird right there. My daughter has a bird. Okay, what do you notice about inscribed angles? This is an example of an inscribed angle, okay? We've learned about central angles, where the center or the vertex is at the center of the circle. An inscribed angle has its vertex on the other side of the circle. So this question is asking, move the red points to see what an inscribed angle does. And I think I'm just going to say, the vertex of an inscribed angle is on the circle. Slide 35, what do you wonder about inscribed angles? Now drag the points and you will see that no matter where you put the vertex, the measure of this central angle, right, we know is the same as the measure of its inscribed arc. But if I take these two endpoints and take this vertex and throw it back on the other side of the circle, it doesn't really matter where I put it. The measure of that angle is still going to be 49 degrees. 49 is actually half of this arc. So that's the relationship that we're learning about. Drag the points, do you wonder, okay, well, let's not fill that out. Let's get to the next one. Take a close look at arc AC and angle ABC. This is the exact same concept. Now they're moving the point for you. Arc AC does not change. Does the measure of angle ABC? ABC. You can see it stays the same, just like in our last example. So I'm going to say yes or no. Does the measure, does not change. Does the measure of the angle? No. I'm going to write angle ABC is remains the same. And whatever you write there is really just for your own use if you're trying to study for a formative or a summative to help you remember what's happening on that slide. This is an example of what these types of problems look like on your SOL. They usually draw a diagram that looks very similar to this, where they have a central angle, they've got an arc, and then they also have an inscribed angle. Angle AOC and angle ABC both intersect at arc AC. The measure of angle ABC is 45 degrees. 45 degrees. So can I write that on there? I don't know if that's, we are about to find out. No, that's fine. With these two things in mind, what is the relationship between the measures of angle AOC and angle ABC? Okay, we can see that this central angle is 90 degrees, which makes the measure of this arc AC also 90 degrees. And they told us that this angle ABC is half of that, 45. So we're just gonna write that out somehow, and you can write it however you'd like. I'm gonna say angle ABC is half of angle AOC. Now we're going to apply it. Trace the angle STL. STL, central angle. If the measure of angle STL is 68 degrees, what is the measure of arc SL? Okay, well, let me take that information and put it on our diagram. Angle STL is actually a central angle. So the measure of its inscribed arc should be the same. So it's asking for the measure of arc SL, that should also be 68 degrees. We can measure this arc also in length, which we're going to do later in the unit, but right now we're measuring it in degrees, and it is 68 degrees. If they were asking us for the measure of this angle here, this inscribed angle, SRL, that would be half of 68. So what is the measure of arc SL? I'm just going to write 68 degrees. Slide 39, if the measure of arc RS is 154 degrees, 154, and here is arc RS, RS. What is the measure of arc RLS? So they can give you a diagram and ask you really anything. In this problem, they're not even asking about those angles. They are asking about the measure of this arc here, RLS. We know that's a major arc because it's using 3 letters. This arc here, RS, is a minor arc because it is given to us in 2 letters, which means it's going to be less than 180 degrees. But we know this one, RLS, they named it with 3 letters, we know it's going to be greater than, or 180 or greater. The entire circle is 360 degrees. So we're just going to take 360 and subtract our 154. And what is that? 206. Perfect. Slide 40. Enter the measures for angle I and angle C in the table below. So what they want you to do is they want you to just move, well, let's do the first one first. They have here, the measure of angle I is 35 degrees, the measure of angle C is 71. Now they want you to change the measure of angle ABC, or sorry, ACB. Here we go. And then record the measurements. You can change it however you'd like. I'm just going to move it around and then record my measurements over here and look at the relationship. And you should have different angle measures here, but we should all get the same relationship. So angle I, 53. So angle C is 107. I'm going to move it again. 27, 54. Last one. 17, 35. So you can see the relationship between the measure of angle I. Angle I is half of angle C. You guys getting this as well? Any questions? It's Friday. So I'd like for you to fill this out. This is our last slide. Oh, this is Reese's guinea pig Harriet. Or sorry, Reed's guinea pig. So flippin' cute. I'm gonna see what you guys write here. Let me pull this up. No responses yet. What would you tell a classmate that was absent? And there are a lot of people absent today. So this is a great video for those of you guys that are absent. Let's see. What is important about inscribed angles? Anyone? Someone write something for my video so I have content. America wants to know. Justin Bieber wants to know. Y'all, my team is playing today at 4:30. Couldn't be a worse time though to play. 4:30. Gonna have to listen on my phone. The vertex is on the circle, okay? Somebody else. Y'all are typing, right? I'm not the only one that's doing work today. I know it, I can feel it. Type something and you get a lollipop. You guys know better. You're like, Helen, you're gonna give me a lollipop no matter I type something or not. All right, angle. Please no lyrics to the Bee Movie. Something, wow. I did ask you to type something, my pleasure. I'm not wearing my Chick-fil-A shirt today, y'all. And Faith usually types my pleasure. And she's not here, so you're doing it for her. Formed when 2 chords intersect. Okay, the vertex is on the circle. All right, fine, good enough. All right, thanks, America. Thanks for coming out. Booyah. Root for VT, 4:30.